Today we are going to be looking at a full version of sine with not just amplitude and period, but with amplitude, period, phase shift, and vertical shift. So we're going to kind of go back over the things we talked about. The amplitude is, remember, it's just the absolute value of A, and we're all going over here. We're kind of go back, we're looking at A, B, H, and K. So here we're going to have the period, which is 2 pi divided by B. Phase shift is H over B, and vertical shift is K. One thing to note about the phase shift, this negative sign is built into the problem. That means that H is always the opposite of the sign you see here, right? So here, my H is going to be just pi. So it's always the opposite sign of this section right here. So you got to make sure to fix those kinds of things. All right, so I'm going to go to I label this just to make sure that I don't mess the signs up. And really the one that I have to worry about is this one right here. I always make sure that the H I'm pulling out of there is opposite of the sign that you see here. Okay, so here we have A of 2. That means amplitude is 2. My period is 2 pi divided by B. So in this case, it's 2 pi divided by 2, or just pi. My my phase shift, which is a lot like horizontal shift, it's just H divided by B. You can see that here. And vertical shift, this is one of the easiest, just equal to K. Previously, when we were working with problems, we were starting all of our functions at the origin. Well, with a phase shift in play, it means I'm moving left or right, depending on which way this value is. If this is a minus value, we're going to the right. If this would happen to be 2x plus pi, I would be going to the left. One thing I'm going to do is I'm going to write out my starting point, and for sine and cosine, that starting point is going to be my phase shift. That's going to be the place I'm going to start. Sometimes it'll be on the positive side, sometimes it'll be on the negative side, and I'll just kind of have to take that one at a time and work with it. Fortunately, this one, it's going to be on the positive side. All right, I'm going to do a couple things. Number one, I needed to find my increment, and I'm going to use my midline. That would be my vertical shift of 3. We're going to put this down first. Then we're going to use our A value, right? Our amplitude is 2. We're going to go up 1, 2, and go down 1, 2, and label these values appropriately. Okay. Now we take our starting point. This is really the hard part of getting all these values at the bottom. I'm going to take my starting point, which is my phase shift, and I'm going to put it down just kind of out in the front here. I'm not really trying to make this to scale. It's kind of like I don't have to make, if this is really close to 0, really far away, I'm really not trying to make that accurate. What I am trying to make accurate is the steps afterwards. So just like before, we put our starting place down, and then we added 1, 2, 3, 4 steps. And here you can see I'm adding my increment. So I start here with pi over 2 plus pi over 4. Well, a common denominator is going to be 4 here. So I'm going to go down, I'm going to change that to 2 pi over 4, and add 2 plus 1 to get 3 pi over 4. At that point, I'm going to take that, and I'm going to go 3 plus 1 would be 4 pi. Plus 1 is 5 pi, plus 1 is 6 pi. So I'm just adding 1 to the top numerator. Basically, I'm adding 1/4. Since they all have fourths already, it's easy to add those values together. And of course, I have some that will reduce. If they do reduce, the even ones, I reduce them to whatever they're going to be. Right? Eventually, I'm going to stop kind of writing it like this. I'm just going to go ahead and reduce it, but we're still learning it. And I remember this is a sine function. It's positive, right? So I'm going to start with my first point here, my initial point. I go up to its max, down to its minimum, and then back to its midline again. Be careful. This first initial point, your starting point, this is not on the y-axis anymore. It's going to be out front or behind the y-axis. It can be either direction. But make sure you're not accidentally starting kind of on the y-axis where we were originally. If this is not here, there's no h, I'm definitely going to be starting on the y-axis somewhere. Here, I'm going to draw just like we did before, but we're going to make sure to start out in front just a little bit. And this is graphing a full version of sine with vertical shift, amplitude changes, period changes, and phase shift changes. Take this real slow. Getting these numbers on the bottom, that's the most critical step. We do that by finding a starting point, which is our phase shift. Finding that increment, remember that was just period divided by 4, and then basically adding fractions. And once I get the common denominator, everything's going to be in that denominator, so I just kind of go through it. We're now going to look at a cosine function with a few fractional values and a reflection over the x-axis. We can see that reflection indicated right here by the negative sign. So let's do the first things first. We're going to write down a, b, h, and k. So we have -1 for a. We have b as 1/2. That's 1/2 x. And then we have a pi/2 for h and a -4 for k. If we remember earlier what our formulas were, absolute value of a is, of course, my amplitude. That's easy. It's just +1. The period is going to be 2 pi divided by our 1/2 here. If we kind of write that down up top, we'll see that we're going to multiply by that reciprocal. So 2 times 2 obviously gives me just the 4 pi. The phase shift is h divided by b. So we're going to make sure, and remember this one is always the opposite of the sign here. So we had a -pi/2, so this is positive. We're going to go ahead, we're going to multiply this up just like before, but this time we have a fraction. Top was on 2 and a bottom on 2. So these are really going to cancel, just giving me pi. That actually is a really nice thing. It'll make our problem kind of easy. Phase shift obviously is just exactly what k is. One of the first things I'd like to do is just to come over here and add the value at my midline, right? That would be whatever my vertical shift is. And I'm going to go up 1 by adding the amplitude. So -4 plus 1 is -3. -4 minus 1, -5. And I'm going to essentially, now I'm going to kind of fill in these values. So the first thing I need to know is my increment and my starting place. The increment is something I do need to calculate. It's 4, or whatever the period is, divided by 4. That's really nice. It's just going to be pi. My starting point, this isn't something I really calculate, especially if I have the phase shift, because the phase shift for sine and cosine, that's going to be my starting place. So I'm going to put that down right here. I'm going to add my 1, 2, 3, 4 places, and I'm going to add the increment. This is really great because no fractions, yay! Add 1, add 1, add 1, add 1. I really kind of double check. This is a mental check. From here to here should be the period. Well, that's exactly 4 pi, right? 1 pi plus 4 pi is 5 pi. If that is not my period, then I have messed up somehow. Sometimes it's easy, like this one, sometimes it's not. When I go to graph it, this is super important. If I have a negative sign here, that reflection, I have to be careful and I have to make sure I note that. I draw the graph upside down, right? So normally we start cosine at the top and we drop it down like this. But here we're going to do that backwards, so now my maximum becomes a minimum and it follows through all the way. And that's how you would graph a cosine function with a reflection and having fractional values. And for my b and my h, it didn't really matter. In fact, because we had fractional values here, it actually made the period and the phase shift turn out to be nice whole number values, and it turned out to be one of the easier functions we've graphed, even though it's quite complicated in terms of its full-size nature. We graphed the cosine function with fractional values for all of the amplitude, period, phase shift, and vertical changes. Take this to heart. Pay attention. The only difference here is that our starting place changes, and my midline, I guess, it's my vertical shift. If you can make these changes just to our starting places, then graphing this function, just like yesterday's function without these changes, the process isn't any different, right? Having a starting place and noting it is my phase shift, and using the increment just like yesterday allows me to get all of these values. And that makes this graph a lot like what we did yesterday. Please watch this as many times as you need to. If you got questions, please send them my way, and hopefully we can get this nailed down. We're going to practice this. In fact, we're not really going to do a whole lot tomorrow. We're going to kind of just stick around here. We're going to practice some more and just make sure that we can get these things down. Make sure that you have the basics, the original sine and cosine function, their parent function. Make sure you have that down in your mind. Be able to draw that from memory. Right? That's gonna be a big help, noting the patterns and things like that. All right, I hope this helped out. We'll see you next time.